Morning. I'm told that yet again we have not reset our clock in the back of the room, so despite the fact that it tells us it's 9:29, I think we are a few minutes after the appointed hour, and we will go ahead and get started. My name is Marion Blakey. I'm chairman of the National Transportation Safety Board, and I'd like to introduce my fellow board members here with me today. Beginning on my right is our vice chairman, Carol Carmody. To my left, John Hammerschmidt. Again, to my right, Member John Golier, and to the left, Member George Black. Today's meeting is commonly referred to as a Sunshine Meeting. Under the 1976 Government and the Sunshine Act, multi-member federal agencies are required to conduct much of their business in open session. While the public is invited to observe these meetings, only the board members and the NTSB staff are permitted to participate in today's discussion. A few weeks ago, the NTSB staff submitted for the board's consideration the following two reports. The first is titled The Sinking of the U.S. Amphibious Passenger Vehicle Miss Majestic, Lake Hamilton, near Hot Springs, Arkansas, on May 1st, 1999. The second is the Derailment and Hazardous Materials Release of Union Pacific Train QFPL I-26 near Eunice, Louisiana, May 27, 2000. Board members have had several weeks now to study the staff's reports. In fact, while board members were permitted to individually meet with staff to discuss the reports, today is the first opportunity board members have to discuss the reports together. Because the reports are being considered by the board today in draft form and do not reflect the views of the agency until adopted by the board, they are not available to the public at this time. During today's meeting, board members will examine each section of the report and may solicit staff comments and explanations on many issues. Next, the board will consider the conclusions, probable cause, and specific safety recommendations proposed by the NTSB staff. The board members will then determine if the report should be approved as presented, approved with editorial, analytical, and/or factual corrections and revisions that have been agreed to during the meeting, or if the reports will be returned to the staff to be revised. The purpose of the Sunshine Act is to provide the public with a window into the board's decision-making process. Deliberations over a draft report can take anywhere from 90 minutes to many hours. Sometimes all or part of a draft conclusion, probable cause, or recommendation will be revised or rejected by the members. Approximately 30 minutes after this meeting, copies of the abstracts containing the conclusions, probable causes, and recommendations approved by the board can be obtained from the board's Public Affairs Office in room 6201. Now, let me turn our specifics today to the accident reports at hand. Dan Campbell, the Managing Director of the National Transportation Safety Board, will introduce the NTSB staff that prepared our first report.
Good morning, Madam Chairman, Madam Vice Chairman, and members of the board. With me at the front table to my left is Ron Batacci, the agency's general counsel, and to my right, proceeding down the table, Marjorie Murtaugh, the director of the Office of Marine Safety, Don Terrell, who is the project manager for this report, Ash Chatterjee, who is the Marine Engineering Group chairman, Rob Henry, who did survival factors, and the investigator in charge, Bill Woody, is at the end of the table. I believe that Don Terrell has the opening statement. Don?
Good morning, Chairman Blakey, Vice Chairman Carmody, and members of the board. This morning, staff will be presenting the sinking of the amphibious passenger vehicle, Miss Majestic, which occurred in Lake Hamilton near Hot Springs, Arkansas, on May 1st, 1999. The Safety Board was notified of this accident at 1700 on May 2nd, 1999, and immediately launched an 8-person team to investigate. The team consisted of an investigator in charge, augmented by marine engineering, human performance, and survival factors investigators, as well as by representatives from the board's Office of Government, Public, and Family Affairs. Member John Hammerschmidt served as the board member on scene for this investigation. The accident was investigated independently of the Coast Guard under the Independent Safety Board Act of 1997, in accordance with the board's rules of practice. Parties to the investigation were Garland County Sheriff's Department and Land and Lake Tours Incorporated, the owner of the Miss Majestic. Although offered party status, the U.S. Coast Guard declined to participate in the board's investigation. After providing an overview of the Miss Majestic accident, we will also present overviews of two other amphibious vehicle accidents investigated by the board: the sinking of the Minnow, an amphibious vehicle of the Alvis Stalwart design that sank in Lake Michigan near Milwaukee, Wisconsin in September of 2000, and the sinking of the Duck No. 1 in Lake Union near Seattle, Washington in December of 2001. Brief reports of these two accidents are included in the notation item for the board's consideration and adoption along with the Miss Majestic report. Like the Miss Majestic, both of these amphibious vessels sank because of poor maintenance practices. Unlike the Miss Majestic, however, there were no fatalities in either of these subsequent sinkings. Before I review the sequence of events in the Miss Majestic accident, I would like to take a few moments to give you some background information concerning amphibious ducks in general and about the operation of Land and Lakes Tours Incorporated, the owner of the Miss Majestic in particular. Further, I would like to tell you some of the unique features of the Miss Majestic which will help to clarify the discussion of the accident. The Miss Majestic was a converted World War II vintage amphibious craft. It was designed for wartime operations with a life expectancy of only a few months. These vehicles were given the military acronym DUKW. The D meant that the vehicle was a 1942 model. The U meant that the vehicle was amphibious. The K meant that the vehicle had front-wheel drive, and the W meant that the vehicle had rear-wheel drive. Commonly, however, these vehicles were known as ducks. Ducks were designed to transport military personnel and supplies ashore during amphibious landings. More than 21,000 ducks were built during the war, and the duck was capable of carrying a 2.5-ton payload over land or water. Ducks were originally manufactured by General Motors Corporation and were 31 feet long and slightly more than 8 feet wide. They were equipped with six-wheel drive for operations on land and a propeller for operations on water. The top speed on land was between 50 and 55 miles per hour, while the top speed on water was 6 knots. After the war, these vehicles were sold as surplus, and many were converted to carry passengers for hire on excursion tours. According to the Coast Guard, there are 63 ducks in commercial passenger service under Coast Guard inspection jurisdiction. There are at least 40 more ducks in commercial passenger service that operate outside Coast Guard jurisdiction, mainly on state waters in the state of Wisconsin. The Miss Majestic was owned and operated by Land and Lakes Tours Incorporated. Since 1962, Land and Lakes operated a business conducting sightseeing tours in Garland County, Arkansas. Land and Lakes operated a fleet of 8 World War II vintage duck amphibious vehicles. The tours featured attractions around Hot Springs, Arkansas, and nearby Lake Hamilton. Each duck was inspected and certificated by the U.S. Coast Guard to carry up to 32 passengers and to be operated by a one-person crew. The Miss Majestic had been modified extensively from the original military configuration. The vessel was equipped with a 350 cubic inch V8 engine and had an automatic transmission. Drive to the rearmost wheels was eliminated, but it retained four-wheel drive capability. Passengers climbed on board Land and Lakes vehicles by means of a retractable ladder at the stern and proceeded forward to the passenger seating area. The Miss Majestic had 6 rows of bench seats in the main passenger area with 2 seats on each side of a center aisle. 2 more rows of facing seats were positioned on the aft deck near the boarding ladder. The passenger area was covered by a continuous roof canopy and was closed off at the front by a fold-down windshield. At the time of the accident, the windshield was in the raised position. Emergency exit was directly over the side through side openings between the stanchions that supported the canopy. 2 days before the sinking, the Miss Majestic was nearing the end of a waterborne portion of a tour in Lake Hamilton when the operator discovered that the Miss Majestic was taking on water. She noticed that the forward electric bilge pump was pumping a continuous stream of water overboard, and that the Higgins pump, the primary dewatering pump in the bilge system, was discharging water intermittently. She terminated the tour and headed for the exit ramp from the lake and radioed a report of her observations to Land and Lakes ticket office. The company's senior mechanic was dispatched to meet the Miss Majestic at the exit ramp from the lake. The mechanic determined that water was leaking into the hull through a tear in the forward rubber boot for the rear drive shaft housing. The operator drove the Miss Majestic to the Land and Lakes garage for repairs. Repairs were begun by the maintenance mechanics the next afternoon. To repair the leak, he replaced the torn forward boot. In the course of making the repair, he discovered a small tear in the aft boot for the rear drive shaft housing as well. He replaced his second boot the next morning, the day of the accident, and the Miss Majestic returned to service. This slide shows the configuration of the drive shaft housing and the boots. The drive shafts for the wheels were located inside a steel cylindrical housing. Each end of the housing was fitted with a rubber boot that was held in place by hose clamps. This arrangement will be discussed in greater detail in the presentation by Mr. Chatterjee. On the morning of May 1st, 1999, the operator of the Miss Majestic drove the vehicle from the Land and Lakes maintenance garage to the white and yellow duck tour ticket office for its first tour of the day. About 11:35, the Miss Majestic departed the ticket office with 18 passengers on board. The operator proceeded from the ticket office to a nearby park where she made a regular stop to pick up 2 additional passengers. Leaving Hot Springs, the Miss Majestic headed south on U.S. Route 7 to St. John's Island in Lake Hamilton and proceeded to a company boat ramp where it would enter the water. The route of the waterborne portion of the tour called for the vehicle to circle the island and return north on Route 7 to Hot Springs. The operator stopped at the top of the boat ramp to the lake and parked the Miss Majestic. She then activated the switch to the electric bilge pumps and stood up and addressed the passengers. The operator pointed out that the life jackets were stowed on the overhead shelving located underneath the canopy. She intended to demonstrate the proper method of donning a life jacket. However, she was unable to free the jacket which she had chosen for the demonstration because the jackets were packed so tightly together. The operator gave up attempting to free the life jacket and said, "They're up there." She then sat back down in the driver's seat, put the transmission in neutral, engaged the propeller, and let the vehicle roll down the ramp into the water. During the waterborne tour, which followed along the shore of St. John's Island, the vehicle proceeded at a speed of approximately 4 knots. The operator spoke to the passengers, occasionally turning around to face them as part of the guided tour. As the tour progressed, a survivor recalled that he had seen a steady stream of water discharging from an outlet on the port side of the duck forward of where he was sitting. However, the operator did not notice the water discharging over the side and continued with her narrated tour. After about 7 minutes on the lake, the operator noticed that the duck was listing slightly to the left or port side. She told the passenger to move over to the starboard side in order to correct the list. At the same time, water began flooding over the stern of the vessel, and 2 passengers began passing out life jackets. The Miss Majestic began to rapidly sink by the stern. Survivors stated that the vessel sank completely below the surface within a matter of seconds from the time that water began flooding over the stern. Only one passenger, a 15-year-old boy, was able to get off the vessel before it sank. The rest of the passengers and the operator were carried underwater with the sinking vessel. Only 7 passengers and the operator were able to escape and reach the surface and survive. Of the 13 fatalities, 7 were found inside the sunken vessel, and 6 were recovered from the lake bottom at various distances from the vessel. 3 of the fatalities were minor children. Survivors uniformly complained that the canopy hampered their escape and considered it to be the major reason why others were not able to escape from the sinking vessel. The Miss Majestic sank in 60 feet of water in Lake Hamilton, Arkansas, and came to rest in an upright position on the lake bottom. The issues involved in this accident are vehicle maintenance, Coast Guard inspection of the Miss Majestic, Coast Guard inspection guidance, reserve buoyancy, and survivability. After a discussion of the sinking mechanism, we will present a discussion of each of these issues in order. I would now like to turn the presentation over to Mr. Ash Chatterjee, a naval architect in the Office of Marine Safety, who will present a discussion of the sinking of the Miss Majestic and begin the discussion of the issues involved. Thank you very much.
Thank you, Mr. Terrell. Good morning, Chairman Blakey, Vice Chairman Carmody, and members of the board. I would like to start with a couple of slides to show some of the unique features on a duck, and after that I will show a video simulating the sinking of a duck. The first slide, which shows the interior of the hull. This slide shows the interior of a duck's hull with the deck removed. The stern is to the left of the picture. There are no bulkheads or compartmentation inside. The hull is open from bow to stern like a bathtub. At the stern of the vehicle centerline, the raised portion is the propeller tunnel underneath. The 4 raised wheel wells can be seen near the corners. Next slide, please. This is the original housing photograph taken from the Army's duck manual and shows the cylindrical shaft housing and the hose clamps for attaching the boots to the housing. The hinge pin assembly shown here was removed from the Miss Majestic, which I will discuss under the issue of maintenance. Next. This is a typical 4-inch access plug used for greasing universal joints inside the hull and for changing oil from the transmission and transfer cases. There are 3 of those plugs on the Miss Majestic. Now I'll show a 3-minute video. This video was prepared under contract for the Safety Board by a naval architectural consulting firm called JMS. It simulates a duck sinking under circumstances similar to that of the Miss Majestic. This segment gives an overall simple picture of the vehicle assembly. You will see the assembly of the wheels, the housings, the drive shafts, the hull, the chassis. The components of the vehicle will soon be shown. That's the wheels, the axles, and the housings for the drive shaft. That's the hull. That's the chassis girder and the fuel tank on the right corner. That's the deck, it's plywood. There's the coamings, which are not watertight at the back. The seats, the canopy, and the openings around the sides. The next segment will show the duck floating in the water first in the light condition without passengers and then fully loaded with passengers. You'll see that the vessel trims down by the stern in the water, and the freeboard at the stern is only about 8 to 12 inches when it's fully loaded with passengers. That shows the light condition. And full load draft is with passengers. You'll also notice that the forward rear axle drops down about 11 to 12 inches relative to the axle behind it as the vessel enters the water. This drop in the axle and housing stretches the aft boot. This part shows how water entered the duct through the rear drive shaft housing. The boot at the aft end of the rear drive shaft housing has slipped off, will slip off the housing, as you'll soon see. There it is. The housing has slipped off, the boot has slipped off the housing. You can see the shiny steel band clamp on the boot that would have prevented the boot from slipping off if the clamp had been tight. Water begins to flood into the vessel. This is the view with the deck removed. Show how the water enters the hull about midships and then flows aft to the stern because the stern end is lower. After the water level in the stern rises, the water flows forward into the rest of the hull. There are no bulkheads to restrict the spread of water, nor is there any foam to restrict the floodable volume inside the vessel. Consequently, the interior fills up with water and the duct sinks deeper in the water. This segment will show an exterior view of the vessel sinking. When the deck edge sinks and touches the lake's water surface, the vessel is considered to have sunk. That's because once water reaches the deck edge, it will spill into the vessel and swamp it almost immediately because there's no watertight decks above or watertight coamings above either. The duct is an open boat, and swamping it is analogous to filling a bathtub. That ends the video, and I would like to return to the PowerPoint presentation to explain the cause of the sinking in a little more detail. When the vessel was salvaged, we found that the rubber boot had separated from the drive shaft housing. The boot housing and clamp are indicated by arrows on the slide. This separation allowed water to enter through the annular opening between the drive shaft and the housing for the drive shaft. The boot was placed back on the housing, and we found that the boot could easily be hand-turned on the housing. It took another 2.5 turns of the band clamp screw, shown on by the screwdriver in the slide, to tighten the boot onto the housing. When the vehicle entered the water and the axle dropped, it pulled and extended the boot. Since the clamp was not tight, the boot slipped off the housing. The morning of the accident, the mechanic had installed that boot. No post-installation checks were conducted, such as checking for water tightness or having a second person check that installation. The mechanic said that because of the cramped working space under a duct, the clamp might have been cocked relative to the housing axis. A cocked clamp would work itself loose under vibrations when the duct traveled by road or when it entered the water and the axle dropped. Or the screw may not have been fully tightened. The slide also shows a view of the 5-inch diameter housing and the 3-inch diameter drive shaft. It took between 6 and 7 minutes from the time the Miss Majestic entered the water till its stern deck was awash. During this time that the vessel was flooding below deck, the operator was not aware of it. Once the deck was awash, the vessel sank immediately. I will now proceed to the next issue of vehicle maintenance. Staff looked, next slide please. Staff looked at the physical condition of the Miss Majestic, examined the company's maintenance records and practices, and interviewed the mechanics. This slide shows a hull repair using a 14-inch by 6-inch silicone rubber patch under the rear axle. This is not an approved type of permanent repair, as the rubber allows corrosion to continue on the plating underneath undetected, as we found when we removed the patch by hand. This shows a 1/2 inch by a 1/4 inch hole from excessive corrosion near the rear axle. The duct has thin sheet metal hull plating and will corrode unless maintained. A pinhole was also found in the rear wheel well. These holes would cause water to routinely leak into the hull and puddle in the low areas of the hull, exacerbating the corrosion. This shows the forward end of the drive shaft housing with the hinge pin assembly removed. These were removed a long time ago on all ducks in the company fleet. You can see holes in the brackets for the hinge pin to pass through on the right. The hinge assembly was removed to allow a labor-saving shortcut for greasing the universal joints inside the hull. The purpose of the hinge assembly is to support the weight of the shaft housing. Without the hinge, the rubber boots supported that extra weight. The rear boot that was installed only on the morning of the accident is shown here and was a typical previously used boot. The company obtained previously used Army surplus parts and generally used them. The enlarged photo shows surface cracks, multiple circumferential lines and clamp marks indicating previous installations of hose clamps. It also showed traces of green paint from previous use shown by the letter where the letter A is. The Higgins pump on the vessel showed there were several problems with it, and it was inoperative the day of the accident. The slide shows that the overboard discharge pipe of the Higgins pump had separated from the hose connecting it to the pump discharge. This break was not initially evident to me because the upper part of the pipe was on top of the lower part, as it should be in an intact condition when the vessel was salvaged. However, when we touched the pipe, it moved apart, making that break evident as shown on the slide. This is the bottom face of the Higgins pump suction strainer. The strainer filter had a 4-inch by a 2.5-inch triangular section missing from the upper right corner. This could allow the suction to ingest debris, which may have broken off the impeller blade as shown in a later slide. When checking against the Army's technical manual, staff noted that the sprocket that drives the Higgins pump, which is shown in the slide, was installed backwards. This resulted in the chain being misaligned and rubbed against a hull stiffener. This is a photograph taken by the Safety Board Materials Laboratory. It shows that one of the impeller blades in the Higgins pump was broken, and the dashed line indicates the missing portion of that blade. The unmarked arrows indicate the damaged tips of the two other blades. This shows the Higgins pump shaft and keyway indicated by the red arrow. No key was found in the keyway or in the vessel after it was salvaged. A key is required to attach the sprocket to the pump shaft. Without a key, the sprocket would spin on the pump shaft without turning the shaft, and the Higgins pump would not work. The circumferential marks on the shaft indicate that the sprocket had been spinning on the pump shaft. This shows an enlarged view of the corresponding keyway at the center of the sprocket. The metal shavings deposited inside the keyway indicated that there was no key in it to prevent metal deposits from gathering there. Neither the operator nor any passenger on the day of the accident saw the Higgins pump discharge water. The Higgins pump discharges water in a high vertical plume, and the pump discharge is very noticeable. The Higgins pump was inoperative that day. 2 days before the accident, the operator had reported an intermittent discharge of short duration from the Higgins pump. It is very likely that the inner edge of the cocked or misaligned sprocket would intermittently bind on the shaft of the pump or the edge of the keyway, causing the pump to occasionally spurt water. Although, and I will now go into a couple of other maintenance issues that we noted. Although the mechanics performed basic servicing such as checking fluid levels and tire pressures and greasing universal joints to keep the vehicles running and keep the tour business going, the company did not have a preventive maintenance program. Instead, the company performed repairs after a boot leaked or breakdowns occurred. They did not routinely retain repair and maintenance records, follow a servicing schedule, and did not conduct post-repair testing and verification after repairs were made, such as tested the Higgins pump by pumping water. The company did not have any written maintenance procedures or written operational procedures for that matter. The Coast Guard does not require companies to keep maintenance records. However, the Navigation and Vessel Inspection Circular on amphibious vehicles published in December 2000 called NAVIC 1-01, which we will discuss later, encourages owners to retain maintenance records and develop maintenance standards. The mechanics did not have any technical manuals or drawings needed to understand the unique features of ducts and their purpose, such as hinge pin assemblies, for instance. The mechanics had a background in automotive mechanics. In addition, they had gained on-the-job experience with ducts, and this is typical in the amphibious vessel industry. Next. Based on the maintenance deficiencies that we have discussed, staff concluded that Land and Lakes vessel maintenance was inadequate and directly compromised the safety of the Miss Majestic and its passengers. The related element of the probable cause that has been proposed by staff for this accident is also on the slide. Recommendations for remedial action to the company have not been proposed because the company has gone out of business. We will now move on to the next issue, which is that of Coast Guard inspections of the Miss Majestic.
Could I just ask that we take a moment here to see if there are any questions from our board on the broad issues that you've laid out. This is a very good and interesting discussion, and I'd like to make sure that we all have a chance to consider this. I'd like to ask one question which goes to the broad point in the early discussion about the history of these vehicles. Clearly they were not designed for this kind of recreational use. They were not designed to be in use for this kind of period of time by a long shot. There are a lot of questions that arise as to why they're out there in the first place. And while I certainly see the appeal from a recreational standpoint, I'm interested in the question of oversight and permitting. In other words, the authority to operate these both on our roads, public roadways, as well as in the water. Who has oversight and what are the broad requirements there?
As far as the operations on the roadway, my understanding is that it varies in state by state, and that in some states it would be treated more or less as a bus, or as you'd have to get the same type of certification that you would to run a trolley, or that type of thing. As far as the in-water operation is concerned, it's a function of whether or not the waters on which the vessel operates are under Coast Guard jurisdiction. If they are navigable waters of the United States, then if you're going to carry passengers for hire, more than 6 passengers for hire, then the vessel would have to be inspected and certificated by the U.S. Coast Guard. There is a significant number of ducks that are operating on waters that have been declared as not being part of the navigable waters of the United States, and therefore are not under Coast Guard inspection jurisdiction. In that case, they would be under the authority of the cognizant state. We're aware of another amphibious vessel operation in the state of New York as well. It's not a duck, but it's an amphibious passenger vessel, and it operates strictly on New York state waters and is regulated by the state of New York.
And when they were first certificated by the Coast Guard to be first used, which I gather was how many years ago at this point?
Well, Land and Lakes Tour Company had been regulated by the Coast Guard for the last 20 years previous to this accident. The regulation of small passenger vessels by the Coast Guard began in 1958. the inspection of those vessels. So, generally speaking, they would have been under Coast Guard inspection authority since 1958.
And from what I gathered from the text of the report, it sounded like we do not have very good records from the Coast Guard on the early retrofitting that was done on these and the decisions that was made on changes in the design for passenger use.
That's correct. Our investigators went through all of the records that the Coast Guard had on the Miss Majestic, and we could find no record of justification for the equivalencies that were granted to them, than any waivers of regulations that may have been granted to them. There was nothing in the Coast Guard files.
So one could conclude then that at least in terms of the early decision making that was made about the use of these vehicles, the question of how passenger safety requirements were taken into account, we really don't have very good information and good evidence that there was adequate analysis on that. Is that right?
That's correct.
All right. Are there other questions? Vice Chairman Carmody.
Yes, thank you. Good morning. Excellent presentation. I'd like to ask a question about the Higgins pump. I was looking at page 22 with the statement, as with most amphibious vehicles converted from the Army, the Miss Majestic had a Higgins pump. Surely, did not the original design for the Army include a pump? Was this not part of the basis?
Yes, the Higgins pump was part of the original Army configuration, yes.
Well, we're saying as with most. Were there pumps taken out when they were converted?
There were some ducks. I've seen the one that was operated by DC ducks, for instance. They have electrical pumps that of the same capacity that have replaced the Higgins pump.
Not Higgins pumps, but different
That's
pumps.
correct,
That were
yes.
pumped. So all ducks have pumps of some kind?
Yes, yes.
Although it's not a requirement? Not a federal requirement?
I'll probably have to give you a little bit of a long-winded answer to that. The subchapter T, the federal regulations for small passenger vessels, was not written with ducks in mind. They were written for conventional vessels, small passenger vessels. And so they don't address many of these unique features, which the Coast Guard ultimately acknowledged after the accident, and which resulted in their producing the NAVIC to go blow by blow through each of the regulatory items and explicitly state what should be required for ducks. And in the NAVIC, it addresses the need for high pumping capacity. And it goes on it provides calculations on how much water can flow through holes of various sizes. And it concludes that the pump capacity should be consistent with the risk in a particular duck. In other words, it's determined on a case basis by the inspector based on the largest opening that a particular duck might have. That would be used to determine the required pump size. So there is considerable, the NAVIC acknowledges that a higher flooding rate will occur, but it also says that the required pumping capacity to address that depends on a case-by-case basis.
Thank you. But would it be safe to say the Coast Guard would never certify a duck without a pump of some kind?
The requirements for bilge pumping capacity are very minimal, and the NAVIC acknowledges that that's what is basically required. In one part of the NAVIC, it does say that if it had a carrier bearing which would close that hole, then no additional pumping capacity is required. But where there is no carrier bearing, then the amount of pumping capacity needed varies depending on that particular boat. So the Coast Guard is ambivalent. It leaves it up to the inspector. It is over and above the basic requirements, and it's really left up to the judgment of the inspector according to the NAVIC. But prior to the NAVIC, it was not addressed at all. It was done, as was previously mentioned, by what had been previously accepted. For instance, there was no basis for equivalencies that are stated. So then inspectors assumed that what was accepted in the past must be acceptable now.
I don't want to beat this to death, but even though the NAVIC recommends it or says it's required, that is still not a requirement. That's guidance to the inspector. Is that correct?
That's correct.
Okay. All right. So if the Coast Guard's ambivalent, I would imagine the operators might well be confused about this as well.
That's correct.
Because I'm confused. Thank you very much. That's all I have.
Thank you. I would like to follow up on the Vice Chairman's line of inquiry, basically with an editorial suggestion concerning some description of the Higgins pump and the other pump's operation, which are found on page 52. And beginning on line 2, we say the Higgins pump, which was the primary dewatering pump, and one of the electric bilge pumps were inoperable. Although the other 2 electric pumps were operating, their combined pumping capacity was less than the capacity of the Higgins pump. And a page or 2 before, we cited the capacity of these different pumps, and editorially, should not we say, was considerably less than the capacity of the Higgins pump? According to my math, we've got a factor of the combined pumping capacity of the 2 electric pumps was 30.5 gallons per minute versus 250 gallons per minute for the Higgins pump. So it wasn't only less, it was a lot less.
Yes, it is considerably less.
Right. Okay. And also, if we're doing some wordsmithing, on the next line where we say, thus, there was no active means of eliminating the water buildup and of alerting the operator to the vehicle's condition, should we not also say, and there was no active means of eliminating the water buildup and no bilge alarm or Higgins pump discharge to alert the operator of the vehicle's condition? Just to complete that picture a little better.
Yes.
That would be my suggestion.
Yes, that's what's implied here. Yes, that would
Right.
be more explicit. Yes.
Okay. And that's all I have in this section.
Member Goliath.
Oh, I might mention one thing, just for the benefit of those that may not have studied this report very carefully. When we were on scene, someone described to me what actually occurs when the Higgins pump is activated and is discharging water, and it is a real prominent plume of water that goes out from the side of the vessel. I mean, it's inescapably gets everyone's attention. So just want to make that last point.
And I might make note of the fact that we have the benefit of Member Hammerschmidt's having been at the accident scene and also having chaired the public hearing on this accident. So he has certainly followed this in detail for a long time. Member Goliath.
Yes, Madam Chairman, just one comment. When we talked about how long these vessels have been operating in this environment, there is at least in the records that I have, a letter from the original Wisconsin Ducks to then Chairman Hall that says that they've been operating ducks since 1946. So they considerably predate the Coast Guard's involvement. And it's also interesting to note that they've never had a problem in all those years. And that's all.
Member Black.
Could we put up the graphic again of the boot assembly?
Slide 2.
If you can't find it, that's okay. Almost. I guess the original one that was in the report, only a couple of figures deep. Well, that's good enough. Put that one up. Pretty clearly, the water, the integrity, the watertight integrity of the hull is dependent on these boots. Is that not correct?
Yes.
And as an engineer, not a marine engineer, but as an engineer, it's pretty clear to me that this is, they say that this was a vehicle that was designed for a short tenure. I might say it was almost designed for attrition. And because this is not the way I would imagine this would be done on a vehicle that was intended for long and heavy use. Is that true, Ash?
Yes, this, holding that boot in place with a single hose clamp on a smooth surface would seem to be almost like a temporary arrangement.
Okay, thank you. So the boots then, obviously, because we've already said that this is formed a conclusion that this is a major, or the cause of the accident, this boot slipping off in this particular case, makes you wonder about not only the quality of the maintenance, as you so accurately described, but the quality of the parts. And it was nowhere clear to me in the report, is there such a thing as a new boot? Does someone still make these things?
Yes, the issue of used parts, this particular owner and their mechanics told us that they had difficulty in obtaining parts because ducks had not been produced in for over 50 years, and so they were using previously used Army surplus parts. Now, there are a couple of large duck refurbishers who have large facilities, for instance, the one in Branson, who have welding facilities, sheet metal facilities, welding facilities, and manufacture ducks for people and sell them to people, and they actually manufacture new boots. It is not clear to me what the economics of supply and demand are when if they were to sell the boots to competitors. I don't have the information on that, on the pricing. Most small operators like Land and Lakes would end up buying used parts, but they are available. I just don't know what the price differential would be.
But surely the surplus must be finite about how long I'm concerned about the future. These things are out there now, and they're going to continue to be out there. And it would seem to me that this critical part here, a large operator was relying on used parts, which was pivotal to this particular accident. This whole issue this fails the intelligence test somewhere along the line about operating these devices with a critical part that's used. There's only one, and apparently a small source of new ones.
Yes,
the Coast Guard is happy with that situation, or do they get into that much? Or somebody ought to be concerned about this, it would seem to me. I guess is what the bottom line is.
Yes, the Coast Guard, as we will discuss under inspections, did not pick up or note the deficiencies in the boots. They did not look closely enough most of the time. And it is true that eventually the existing parts will run out. Coast Guard does not prescribe where operators should get their parts from. They don't prescribe, they don't get into those areas. But certainly the bottom line that the parts that are being used should be reliable for the purpose, for the service intended. That is indeed the Coast Guard's responsibility.
Thank you. I didn't mean to get into the other area, but I think the chairman made a good point. Here you have a vehicle that's on the road that I guess is certified as some kind of a truck or a motor vehicle. Does this thing have a state inspection sticker on it? Or does Arkansas have a state inspection? There's the Arkansas expert.
Well, in terms of this commercial vehicle, I believe that it would need to be inspected, but I'm not clear on that in terms of road inspection. In terms of automobile inspections, Arkansas used to have a state inspection process, and they did away with it.
So did Georgia. So
for a variety of reasons.
but it's an issue here about we people who ride on devices like this or would assume that someone's watching out for us. And it appears that you've got an amphibious vehicle that is of limited quality design, I guess, to begin with, that is seen a life far beyond. I'm just concerned. Maybe we'll get into this in another area, but it concerns me greatly that this large operator, relatively large operator, is relying on a source of used boots. It seems like they would automatically want to wonder what happens when we run out of used boots. Is there another source, and what can they do? So, thank you, ma'am.
If I might just follow up on some of Member Black's points. Of course, this report really focuses on the marine side as opposed to the the land side of operation. And there are aspects to the mechanicals and the overall design and the maintenance, et cetera, that relate to one another between the two. And there's trade-offs here and there as we've studied this issue. I would suggest that following, I think, Member Black's very perceptive point, that the report is not really clear on the fact that new rubber boots are available. And I think we need to put a small reference to that effect in the report to clarify that issue somewhat, because I believe on page 29 we make reference to, I'd even made a point on that, page 29, line 12, that this operator in Hot Springs was relying on these Army surplus boots, these older boots, and we do need to footnote or something to say that new boots are available.
In fact, if I could follow up on that point, because I think this is helpful. I mean, obviously a great deal of what we're trying to achieve today, in addition to determining the probable cause of this accident, is following the safety of these vehicles as they're being in use now. What can be said about the degree to which these vehicles really do represent World War II vintage surplus parts and original equipment, and to what degree are we talking about vehicles that have been significantly modified, retrofitted, and a great deal of the working parts essentially are adapted to modern use? I don't have as clear a picture of that as I'd like to from the report.
If I might, Chairman Blakey, we have several slides that show the amphibian vehicles in their original configuration and in their modern configuration. And at the bottom, you'll see what their original bilge pump capacities were, for example. And their, for the Miss Majestic, I believe it was a Higgins plus 43 gallons per minute. For the original military version of the Duck, I believe it was 360 gallons per minute for the original pumping capacity. And that's for a Duck. We also have it for a Lark. The military version had 900 gallons per minute. They currently have 186 gallon per minute pumps. And you can see the difference between the military version and the modern modified version. And the same thing for the Alva Stalwarts. And I don't believe we could get the original bilge pumping capacity for those, but that's a military version versus a modern version with a 47 gallon per minute pump. Please go ahead, Ash, if there's a correction, please.
Yes, the Stalwart has a capacity of 2 times 6, 12, plus 15 on a hand pump. That's 27.
That's helpful, and I appreciate that, because that's obviously very critical. The larger question I was going to was to what degree these vehicles, what you all have learned in your discussions with the industry and as you have worked on these issues, about the degree to which these vehicles now represent original equipment, very old parts, adapted in a makeshift capacity, versus to what degree are they truly retrofitted, different, and other at this point. I don't have a very good sense of that, and perhaps you can't generalize, but I assume you've been in touch with the industry enough to give us some ideas about that.
Yes. Other than the Land and Lakes Duck, Miss Majestic, and that company, I had investigated the sinking of the Duck 1 in Seattle and visited the factory at Branson that refurbishes ducks. And I found there was a variation, a significant difference between the two companies. The one in Seattle, which was using ducks that were manufactured by Branson, the hull had been refurbished. It was in good condition. The hull was in good condition. The pumps are rebuilt at Branson, and before they sell it, they rebuilt Higgins pumps where there's a need. Their boots are new, and they have an improved design with a double clamping arrangement instead of using a single clamp. So there are operators that have taken measures to extend the life of these ducks and the safety of these ducts, and there are those operators that have not done those and have left it in their original configuration that was meant for a short tenure. So there is that difference. With an older vessel, one would need to pay attention to the maintenance issues and pay appropriate attention to those items that are more vulnerable. But this got its the onus for these changes occurred. Much of it occurred after the accident.
That's helpful. All right, are there any other questions?
Ash, somewhere along the line, we were talking when you were talking about the boots. I recall the new boots having the ability to have double clamps on them as well.
Yes, that's what I mentioned. The ones that are manufactured by Branson, they have double clamping boots on the new boots.
So they're essentially a new and improved version.
Yes.
And I know that you visited a couple of the duck operators after I have. Were there not some that were looking to replace power plants with more modern engines and
I'm sorry, replace the power plants with?
Yeah, replace their engines with more modern. This was a 6-cylinder flathead engine. And
Well, these engines that are in the current ducts that are used are not the original engines. They've been replaced, and I'm not up to speed on if they have been changed into, real modern engines. But these are not the original engines that was in the Miss Majestic.
Okay, and switch gears to bilge pumps now for a second. Again, my recollection of some of my visits was that there was a heck of a lot more capacity in some of these operators than what we had on that screen for bilge pumps. Is that, mainly Boston ducts and Branson ducts? I thought there was 6 additional pumps in over and above the Higgins pump.
I believe that with the Higgins pump being there and the additional, I know that DC ducts has 6 electric pumps, but they do not have a Higgins pump. But I do not know if Boston ducts had 6 additional pumps in addition to the Higgins at that time. I'm not sure of that.
Okay, I picked it up someplace and I didn't visit DC ducts, but that doesn't matter really. Thank you.
All right, if there are no other questions, I'd like to suggest we go on to the Coast Guard section of the presentations.
Staff, on the issue of Coast Guard inspections, staff reviewed the annual inspection records from the Coast Guard from 1994 through the most recent one at that time on February 23rd, 1999, examined the physical condition of the vehicle, which we discussed under maintenance, and interviewed the last inspector and his supervisors. And based on that information, staff concluded that there were serious deficiencies with the inspections and the way they were conducted during that period. And it had not been very long since the last inspection in February till the sinking on 1st May. First, staff noted that all inspections were conducted in the owner's garage. None of the inspections were conducted with the vehicle in the water. Now, inspections in the water can reveal safety problems that on-land inspections cannot, and especially those relating to the watertight integrity of the hull, such as hull corrosion. And this slide, which you've seen before, shows the corrosion of the hull, even though the vehicle had operated in a freshwater lake, which means that it probably existed for a long time, but had not been identified as a deficiency by the inspectors. And this is not, the rubber repair patch is not an approved type of permanent repair, but it had not been identified as a deficiency by the inspectors. Since the hull plating is thin sheet metal, greater attention needs to be paid by inspectors for maintenance of the hull. The Navigation Vessel Inspection Circular, which we will discuss later, highlights the areas of a duck hull that requires closer inspection, just to highlight it in the minds of the inspectors. The next slide shows the shows the absence of a hinge pin assembly, which was not noted by the inspectors, even though it had not been there for past several years. That's mainly because the inspectors were not aware of the importance of the hinge pin assembly and that it should have been there. Their knowledge base was lacking in that regard. Next slide. If you go back to the previous slide, Tom, none of the bilge pumps, the Higgins or the 3 electrical pumps, were tested with water. The inspectors stated that they made a visual check of the pumps, but it is very difficult